Hello friends, this is Dr. Sudhan Sharma from School of Computers and Information Sciences, Indira Gandhi National Open University. I welcome you to this session of examples of algorithm and flowchart. In the last session, we understood what are algorithms and what are flowcharts, how they are different from pseudocodes, and we understood that what is the relevance of different notations in the flowcharts and what will be the possible problem if the suitable notations are not used when designing a flowchart. We understood that algorithm is in fact a well-defined sequence of steps that provide a solution to a given problem, but flowchart is actually a symbolic representation of algorithm, and we actually compared in the last session that a flowchart how simplifies the work of a programmer and a team which is responsible to develop the documentation of a program. So, flowchart seems to be quite simple, but at the same time it is not easy to implement the flowchart, and we discussed about different advantages and disadvantages of the flowchart. We identified that flowchart is a standardized format and which is very difficult to alter, and it is actually specific to a problem in particular. And the thing is that the advantage is that it is very straightforward. Even a person who is not from the programming environment can interpret and analyze what the system is planning to do, and based on this understanding, the flowchart can reveal that what could be the possible outputs. So, we compared algorithms and flowcharts. Now, in this session, we are trying to explore different examples, different type of problems with the help of algorithms and the flowcharts. With the very first example, we did it in the last session also, that we need to compute the area of the circle. Now, in this session, we are comparing the algorithm and the flowchart hand in hand in the same slide. Now, we knew that algorithm is a set of instructions in a particular sequence required to solve a problem, and that problem solution involves the processing of the input and to provide the output as a solution. So, there are three stages, that is, we are having an input, we are having processing, we are having output. So, to find the area of the circle, firstly we should understand that what should be the input. The input of the input is actually the radius of the circle. Now, processing relates to the calculation of area. So, we should understand what should be the formula. The formulation is required. So, the formula for calculation of the area of the circle is pi r square, that is pi into radius into radius. So, radius is to be multiplied with the factor of pi, and this is in fact the processing, and output, that is the calculated area, is printed as an output. Now, looking at the flow chart, we start the problem, we need the input, that is input is the radius, and we calculate the area. That calculation of the area turns out to be pi, that is 3.14 into radius, and we display the output as an area, and the problem is solved. Now, this type of problem is very sequential, that means each stage has got particular solution. Now, there is no looping, there is no conditions, and the situation, the states are changing in sequence. Now, let us see one more problem of the same type, but here some more calculations there, that apart from multiplication, you are performing addition and subtraction types problems also. Likewise, say you need to convert the temperature into in Fahrenheit scale into the Celsius scale. You need to have the input in the Fahrenheit scale. Then the expected output is to be in the temperature scale. So, degree F should be your input and degree C should be your output. So, you need temperature in Fahrenheit, that is degree F, and to convert it into degree C, you need to perform some calculation, and this calculative formula is C is equal to 5/9 into F minus 32. So, putting this value of F into the formula, you get that C is equal to is the actual temperature in degree C, and this is what is reflected into the flow chart, that you read it the data in Fahrenheit, and you perform calculation to transform it into degree Celsius grade, and you print the output as the result in degree Celsius. So, this is again a sequential problem, and again I am trying to solve one more problem in a sequential manner, but the complexity level is increasing, that how different functions are being used. Firstly, we discussed that only multiplication is to be done, then multiplication and subtraction are done. Now we are using different functions like the square root and multiplication and subtraction and all those things, how to find the square root of a quadratic equation. You know that the a quadratic equation is ax square plus bx plus c, and the standard roots of the solution of the problem are x is equal to minus b plus minus square root of b square minus 4ac upon 2a. So, that means the entire solution of the roots of this solution of this quadratic equation depends upon the coefficients of the quadratic equation, which are a, b and c. So, inputs should be a, b and c. Then you are supposed to find square root of b square minus 4ac. So, you use the formula SQRT. In the parenthesis, you need b into b minus 4 into a into c, and you store this result into one more variable, say it d, and use this d in another variable which is one of the roots, say x1, and which is minus b plus d upon 2a, and the second root is x2, which is minus b minus d upon 2a. I said that there are two solutions because the problem is quadratic, and the solution are minus b plus minus square root of b square minus 4ac upon 2a. That means one solution is minus b minus square root of b square minus 4ac upon 2a, and second solution is minus b plus square root of b square minus 4ac upon 2a. So, x1 and x2 are the outputs, and these are to be printed, and hence the algorithm should stop. So, this algorithm is mapped into the flow chart, as it is very much visible into the slide, that how this algorithm is mapped into the flow chart. Now, if you want to know that whether the roots are imaginary, whether the roots are real and equal, or the roots are real and distinct, so you need to work with the component b square minus 4ac. If b square minus 4ac is less than 0, then the roots are imaginary. If b square minus 4ac is equal to 0, then roots are real and equivalent. And if b square minus 4ac is greater than 0, then roots are real and distinct. So, now you need to focus on the calculation of b square minus 4ac and try to explore the condition, that which condition is satisfied. So, this algorithm which we saw is modified, and now the flow chart will look like this and algorithm will look like this. So, you take the input ABC, you calculate b square minus 4ac and store it into the variable d or disc. Say if d is less than 0, go to step 7. What is step 7? That output is roots are imaginary, but otherwise go to step 4. Now, what is step 4? If disc disk is greater than 0 is true, then go to step 9, otherwise go to step 5. Go to step 9, if it is true, then that is roots are distinct, otherwise go to step 5. That means all the conditions, that is greater than 0 condition is also false, less than condition is also false. That means one condition is left, that is both are equal. So, that means the output should be roots are real and equal, and the algorithm will terminate. So, this is represented over here in the flow chart. That means you are taking input A, B, C, you are calculating b square minus 4ac. If b square minus 4ac is less than 0, then the output is that roots are real and equal. So, that means this is how the condition, if equal to 0, that means the roots are real and equal, otherwise roots are real and imaginary, or roots are real and distinct. So, that means this is the decision box now we are using. That means we took input A, B, C, we calculated one value, that is b square minus 4ac, and we checked that the result of b square minus 4ac is equal to 0, less than 0 or greater than 0, and based on the satisfaction of the condition, different output are being communicated as output and the algorithm terminates. So, this is how we use the decision box, that is the diamond or the rhombus, to take the decision. So, in this algorithm we explored, we understood that there is a start and stop, the usage of the input symbols, output symbol, and the processing is only through the decision box. Now, let us explain one more example where you need to determine sum of 5 numbers which are to be entered by the users. Now, over here the problem says that firstly you need to initialize the variable sum and count to 0. Sum is actually variable which is storing the sum of 5 numbers entered by user, and count is actually a variable which is taking care of that how many number of inputs are being given by the user. So, firstly the user is asked to enter the number n. Say the number entered by the user is 1. So, as per step 3, sum is equal to sum plus n. So, new value of sum will be equal to 0 plus 1, that is 1, and count will be incremented by 1. So, that means count will again be equal to 1. Now, if 1 is 1 less than 5, yes, it is true, 1 is less than 5. So, let us go to 2, step 2 of the algorithm. So, step 2 again requests another number, that is 2. Say the user entered 2. Now, stored value in the variable sum is 1. New value entered by the user is 2. So, the new value of sum will turn out to be 1 plus 2, that is 3, and count will be incremented to 2. So, 2 is less than 5, again go to step 2. So, this is how count maps that whether the number of values entered by the user is less than 5 or not. And when the moment it becomes 5 or more, the algorithm turns out. Now, this same problem is mapped over here. We find that 2 inputs are being given, sum is equal to 0, count is equal to 0, and we are requesting the user to enter the number n, and we are adding this number n to the variable sum. The actual equation is sum is equal to sum plus n and count is equal to count plus 1. So, is count less than 5? Yes, count is less than 5. So, again take an enter and number n. So, sum is equal to sum plus n, and again it is checked, it is less than 5. Yes, again a new number, and this new number is entered, is added into the value of sum. The moment count becomes more than 5 or equal to 5, then it turns out to be false and it goes out, and the entire sum, that is 1 plus 2 plus 3 plus 4 plus 5, that is 5 plus 4 is 9 plus 3 is 12 plus 2 is 14 plus 1 is 15. So, 15 will be printed and the algorithm will stop. Now, let us make the problem a bit more complex. Say you are supposed to find the sum of first 50 odd numbers. So, immediately you should understand that the numbers should be less than equal to 99, because 50 odd numbers, the range should be from 0 to 100, and from 0 to 100, 99th number will be the 50th odd number. So, say sum is equal to 0, we initialize the variable sum is equal to 0 and number is equal to 1. The first odd number, we are not using number is equal to 0, we are taking first odd number. So, it is sum is equal to sum plus n, that is first 0 plus 1, that is 1. Is num is less than, yes, 1 is less than 99, yes, it is true. So, add 2, so 1 plus 2 will be 3. So, 3 is the next odd number, it again goes over here. Now, earlier value of sum was 1, so 1 plus 2, 1 plus 3, that is 4, 4 is less than 99, yes, 4, now this number will be again added. So, now earlier last number was 1 plus 2, that is 3, now 3 plus 2, that is 5, now again it will go, that is sum is equal to sum plus 5, that again a new number will be generated, and this number 5 is less than 99, then again in this number 5 plus 2, that is 7 is added, and this 7 is added, and a new sum will be generated. So, the 1 plus 3 plus 5 plus 7 plus 9 plus 11, this is how this will go on, and the moment it become 99, it will become 99, it will write the entire result as sum. So, this is one of the solution. Now let us discuss one more problem where we are planning to find the average of the numbers entered by the user. Say 4 numbers are entered by the user, M1, M2, M3, M4, and we need to calculate the average. So average is M1 plus M2 plus M3 plus M4 by 4, and we want to find that a person who is securing less than 50% of the average is fail, and a person who is securing more than 50% is actually pass. So we want to identify that whether a person is fail or pass. So we put decision that if average is less than 50, we need to have the output that it should be evaluated as fail, and if it is greater than 50, it should be evaluated as pass. So what is the input required? Input required is M1, M2, M3, M4, that is marks on the 4 subjects. The processing required is the calculation of the average. So M1 plus M2 plus M3 plus M4 by 4 is the processing required. Now we need to take the decision. If the average is less than 50, yes, print. If less than 50, print fail. If greater than 50, print pass, and the algorithm will stop. So this is how we transform an algorithm into a flow chart by using the different decision symbols, which are your parallelogram for input output, your rectangle for processing, your rhombus or diamond shape for your decision making, and this is how the algorithm will work out. Now there is again a standard problem which is very frequently asked, and that is how to calculate the factorial. Now these problems are actually mapping to the different constructs. Likewise, the earlier problem was relating to the if then else construct of programming, and this problem can be solved either by the looping construct for or while or do while, and this problem can be solved by while or you can also use for construct. We will be discussing about different constructs when we will be taking about the session of C programming or so, that how different constructs are mapped to the different flow chart to solve the different type of problems. Let's here focus on the problem to calculate the factorial of a number. Now say we need to calculate factorial of a number n entered by a user. So let n be the number, and factorial is actually a variable which is actually storing the answer of the factorial of number n, and we initialize these two variable factorial, and we are taking one more variable I, and we are initializing them as 1. So we read the value of n, and we repeat the steps until I becomes equal to n. And when we are repeating the steps continuously, we are doing that, we are multiplying factorial by I and incrementing I by 1. So say we are using this algorithm to calculate 3 factorial. So n is equal to 3. So factorial variable is initialized to 1, I is also initialized to 1, and the real value of n is actually 3. So I is equal to n. This algorithm will run up to I is equal to n. But at present, factorial is equal to factorial into I. So 1 into 1 is equal to 1, and this answer is stored in factorial as 1. And I is equal to I plus 1, that is I will now become equal to 2. And again repeat, the step will repeat it. So factorial is equal to factorial into I. So factorial into I, that is 1 into 2. And again it is 2 is stored in factorial, and I is incremented to 3. Now I is equal to the number entered by user, but this step will be executed one more time, that is 2 into 3. So this is 6. Now I is equal to 4, the I is not equal to n. So what the answer of factorial, that is 3 in 1 into 2 into 3, that is 6, is displayed as the output. Let's map this algorithm into the flowchart. Say we read a variable n, we initialize the variable I and fact as 1. So these are two variables. So fact is equal to fact into I. So 1 into 1. So I is equal to I plus 1. So again let's use this flow chart to calculate 3 factorial. So read n, so n is equal to 3. I is equal to 1, we can take fact is equal to I also, because I is equal to 1, it is one and the same thing. I is equal to 1, fact is equal to 1, or I is equal to 1, fact is equal to I. This is another approach. So fact is equal to fact into IE. So 1 into 1. So fact is equal to 1, and now I is incremented by 1, so I is equal to 2. Now 2 is less than 3, yes, it again goes up. Now fact is equal to 1 and I is equal to 2, yes. So new value of fact will be 2, I is equal to I plus 1, that is 3. Now 3 is less than equal to n, yes, 3 is equal to n, yes, it again goes up. Now fact is equal to fact into I, so earlier value of fact was 2, so 2 into 3. So 2 into 3, that is equal to 6. Now I is equal to 3 plus 1, 4. 4 is greater than 3, yes. So 4 is greater than 3, so it will come out of this loop and will print fact. And the fact is equal to 1 into 2 into 3, that is equal to 6. So this is how you map algorithm with the flowchart. Now let us discuss one more problem. It is a very simple problem but quite interesting, that how to determine the largest among the 3 numbers. So the algorithm goes in this way, that we declare 3 variables A, B and C. So we read these variables. If A is greater than B, the step 4 says that if A is greater than B and A is greater than C, that automatically A is the largest. But if A is greater than B and C is greater than A, then C is the largest. But if A is greater than B and B is greater than C, then B is the largest. Now this step 4 seems to be very complicated over here, but understanding of this step 4 will be very much simplified in the flow chart. This is why the flow chart is generally referred by the programmers, because they simplify the complex instructions. Now let's look at the flow chart. Now here we are entering 3 numbers A, B and C. So we are comparing A greater than B, yes, okay. So A greater than C, yes, so A is the largest. Now A greater than B, no, that means A is less than B. Now subsequently, is B is greater than C, yes, so B is the largest. Now A is greater than B, yes, and A is greater than C, no, that means C is greater than A. A is greater than B, no, and B is greater than C, no, that means automatically C becomes the largest. So from the diagram, from this flow chart, the complicacy of step 4 is easily resolved. This is the beauty of the flow chart, that it simplifies the complex instructions of the algorithm. So I hope you understand that how flow charts are very much relevant for the programmers and the documentation development professionals. Now there is a very standard problem for binary search. In order to understand this binary search, we need to firstly say that there are 2 types of search mechanisms. We say there is a linear search. Linear search relates to that if I want, say there is a list of vowels A, E, I, O, U, and I want to check that a character is given to me and I want to check whether this is a vowel or not. So what I will do, I will use that character, compare it with the first element, with the second element. Wherever the match occurs, I will say that this number is found in this variable, in this list. So this is 1 by 1 comparison. So A is compared with A, at first time match is done and we find. But in binary search, what we are doing, we are splitting a complete list into 2 partitions. And we check whether the element to be searched is less than the middle value of that partition which is sorted either in the ascending order or in the descending order. Generally it is in the ascending order. So we compare the element to be searched with the middle element, and if the element found is at the middle, it is found. If the element to be found is less than the middle element, it is to be searched in the left hand side of the list, and if it is more than the middle element, then it is to be searched in the right hand side of the list. So this problem, let me first help you to understand this problem with the help of an example. Let us say that we need to search for 201 as a number, and there is a sorted list of 1, 10, 5 up to 1000 as it is given to you. And in C, generally the indices started with 0. So index of the first element is 0 and index of the 13th element will be 12. So we need to compare the element with the middle element. So 0 plus 12, that is 6. So we compare 201 with the mid value, that is 101. Now 101 is less than 201. So that means 201 is to be searched in the right half of this list. So to search in the right half of the list, we increment this mid element, this lower bound, to the mid plus 1 value. So the new position will be 7. So 7 plus 12, that is low plus half. Mid is to be found now. 7 plus 12, that is 19. 19 divided by 2. So that is 18.5, that is 9th element. So 7 plus 12, that is 19 by 2. So you are reaching over the 9.5 element. So 9.5, because 9.5 is half of 19N. So that means 9.5, that means relating to the 10th position. And 10th position is nothing but 201. That means by just second division, you are able to find the number. Now let us see the algorithm at first, and then we will apply this algorithm to solve this problem again. So the algorithm is having, the function is having two arguments passed. Say t is the number to be, or the term to be found in an array A. The indices are low is equal to 0 as it is shown over here, and high is equal to n minus 1. 13 elements are there, so 13 minus 1, that is 12. So this is shown over here. While low is less than high, 0 is less than 12, do what you are supposed to do? Low plus high by 2, 0 plus 12 by 2, that is 6. And this situation is, this value is stored in Ix. If t is equal to Ix, what is t? T is the number to be searched, and this is 201. Now, if t is equal to Aix, now Aix is your 101, because 6th position is 101, but 201 is not equal to Aix 101. So what you are supposed to do? If t is less than Aix, what is value at t, that is 201, is not less than 101. But it is said that if t is less than Aix, then high is equal to x minus 1, that is move 12 to 11. Else low is equal to Aix plus 1, that is Aix, what was Aix? That was 6. Move low is equal to Aix plus, low is equal to Ix plus 1. So Ix was 6. So new low will be Ix plus 1, that is 7. So let's apply this algorithm onto this problem. So array is this 1 to 1000. We are supposed to find the element t is equal to 201. Low is equal to 0, high is equal to 12. Low is less than high, true. Do low plus high. So 0 plus 12 by 2, that means 6. Now if t is equal to Aix, now t is equal to 201, but Aix, that is 6th element of the array, is 101. This is not true, so we cannot return the true value. So if t is less than aix, now t is 201 which is not less than aix, so we need not to execute this condition. So we need to execute this condition because t is greater than aix. So low is equal to aix plus low is equal to ix plus 1. What is ix? Ix is position 6. So new low will be 6 plus 1, that is 7, and it will again move up. Ix is equal to low plus high by 2. So 7 plus 12 by 2, that is 19 by 2. So that means 9.5. So 0.5 is rounded, 9.5 is rounded to 10. So that means Ix is now the 10th position. Now t is equal to 201 and aix is also 201. So that means the element is found at the position 10. So that means we are bifurcating, we are dividing the problem into two halves again and again. This is divide and conquer technique to solve the problem. Let us come to the flowchart now. By looking at the flowchart and by understanding the algorithm, you will find here that we are continuously dividing the list into two halves, and we are searching that whether the element is lying in the right half or the left half. That means if the element to be found is greater than the mid value, it is to be searched in the right half. If the element to be searched is lower than the middle value, it is to be searched in the left half. And we subsequently divide the list into further halves and we come to the solution. The flow chart is quite self-explanatory. If you understood the algorithm, you understood the problem solution, you will be able to understand this flow chart in a very well manner. I hope you are able to understand what are different flow charts and applications of flow charts, algorithms, how algorithms and flow charts are actually used by the programmers to solve the complex problems, and this will help you to write the program in a simplified manner. Thank you.